doing problem number 36 from the textbook. And so problem number 36 says, a man 6 feet tall walking at a rate of 5 feet per second towards a light that is 20 feet above the ground. At 10 feet, you're going to find A, the rate of the tip of the shadow is moving, and B, the rate of the length of the shadow is moving. Okay, so for A, we're going to start by drawing out the triangle, just going to represent. So we know that 20 feet is a constant height. We have our person here standing at 10 feet, and person is 6 feet tall. And then we have this space, which we're going to call X. And then we have the total length, which we're going to call Q. So first, we're going to write down what our given is. So we have our rate of which they're walking, which is going to be dx over dt, and that equals 5 feet per second. And we're going to find what our goal, which is the rate of which the length of their shadow is moving, which we're going to call dq over dt when x equals 10. So our equation for this, we're going to use, since they're similar triangles, it's a triangle within another triangle, we can use the ratio between the two, and that's going to be 20 over 6, because we have the height is 20 and then the height of our person is 6, and that's going to be equal to q over q minus x in order to find this space right here. So we can simplify this. So that's all going to look like, so this is going to be 3.3 is equal to q over q minus x. I'll move over here just to make this a little bit easier. So then we can move the bottom to the left side, which is going to be 3.3 q minus x is equal to q. We're going to distribute our 3.3, so we have 3.3q minus 3.3x is equal to q. We can subtract q to this side, which you're going to get 2.3q is equal to 3.3x. At this point, we can take the derivative of both sides, which are going to be equal to what we're given and what our goal is going to be. So that is going to be 2.3 dq over dt equal to 3.3 dx over dt. It's going to be real simple, and we know that dx dt is equal to 5, so this just becomes 3.3 times 5, and we're going to divide both sides by 2.3. All right, so we have our final answer for problem A, which is we're finding out the rate that the tip is changing, so dq over dt. In our calculations, it's going to be 7.17, but wait, we know that in our triangle we're moving towards the light. We have our rate is going to be a negative, and the units on that are feet per second. All right, now we're going to get started on part B, which we're finding the length. The last time I might have misspoke, we were finding the tip, but now we're going to find the length of the shadow and the rate of which it's moving. So I went ahead and drew the same diagram. The only thing that's changed is we have our X section, which goes up to 10 feet, and then we have the length, which is the whole length of the shadow. So we have still the same given, which is our rate of dx over dt, which is equal to our 5 feet per second. But our goal this time is going to be dl over dt when x equals 10 again. So we're going to start just like the one before. They're similar triangles, so we're able to create a ratio of 20 over 6, and that is going to be equal to x plus L this time over L. So we can simplify this into 3.3 equal to x plus L over L. we're going to move over our L to this side. So we're going to have 3.3 L to x plus L. Then we're going to move our second L over, subtract it, which is going to be us 2.3 L is equal to x. At this point, we can go and take the derivative. So the 2.3 stays on the outside, and it's going to be what our goal was to find, which is dl over dt. And we can take the derivative of our x, which is going to be dx over dt. From here, we can set it equal to 5, which we already know, and then divide each side by 2.3. So in the end, the rate of length that it's changing, or dl over dt, is 2.17. But like we had before in the last problem, it has to be a negative because we're going towards the light. And that unit is feet per second.